Welcome everyone. So here we're going to find the area under the normal curve. So this is what we call the normal curve. So sometimes your probability distribution is a normal distribution so that you can use this normal curve, which is related to a z-score table. I'm going to show you that a little bit later, but let's try to analyze this as much as we can. So the normal curve, or sometimes called normal distribution, the mean is right at the center. So this is where the mean is. And often mean is represented by this Greek symbol mu. Now, it is symmetric right at the mean. So to the left of it, you have the negative z-score. So here you have negative z-scores. And to the right of it, you have the positive z-scores. So, and the center, the mean is always 0. So this is going to be 0. Here is the z-score table. So let me show you that. This is the z-score. And every time you read off the area, so all of these are representative area for a particular z-score. For example, if your z is, let's say, negative 2.50, so you read the vertical direction first, and then the horizontal direction gives you the decimal place. 2.50 will give you this area. Now, what that means is on the normal curve, your area is 0.0062 to the left. So for particular z-scores, I'm just going to draw that right here. So negative 2.5, let's say it's right here. So when z is negative 2.50, the area we just read, it reads to the left of that z-score. So every time you read the table, you're reading of the area to the left of that particular z-score. So for this one, we got 0.0062. So this area is 0.0062. So I hope you got the idea on how to read the table for z-score. So let's go ahead and take a look at these examples I have on the left. So we're going to find the area of the following. For number one, we're looking for 5% of the total area to the left of z. So we're looking for what is the z that corresponds to 5% of the area to the left. So let's try to draw a picture. So here's the normal curve. And 5%, so 5% is very small. So let's suppose we're looking for this z right here. So we're looking for what is the z that corresponds to this area. So this is the 5% to the left of that z. So when you read the table, you will get the actual z value we're looking for and the area. So 5% in decimal is going to be 0.05. So on the table, you're going to look for the body of it, 0.05. So going back to this again, we look for the area of 0.05. So I see 0.04 here. So 0.05 will be, so this is 0.05, this is 0.05. So you take the one that's closest. So 0.0505. So these are all good values, but I'm going to go with this one right here. You can even go with that one too, because that's very close to 0.05. So I think I'm going to go with that one versus the one previous to it. So any of these are pretty good for the area 0.05. So this one corresponds to, so the z value is negative 1.6, and the decimal, if you were to use the first one, that's 0.04, or if you use the second one, that'll be 0.05. So your z would be negative 1.64 or 5. So let's go with the first one. So the z is equal to negative 1.65. So that's the z-score that gives you area 5% to the left. Let's take a look at the second problem. 1% of the area to the left. So again, we're going to use the z table. So we want 1% to the left. Suppose this is the normal curve. And let's just say that's we're looking for what is the z that gives us area total 1% to the left. So this is 1%. And if you convert that to a decimal, that's about 0.01. So in the body of the z-square, you're going to look for 0.01 or something close by. So coming back here, so 0.01 looks like 0.01. It's a very small area. So we're going to be right on top. So it looks like you're going to get, so maybe here, 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 here. So all of these are very close. This too. So these are much closer. So the first one we analyzed, they're close enough, but the one we just got second shot, they're pretty better than the one previously. So 0.01, I think I'm gonna go with the first one I highlighted. So let's go with that one. That's pretty close. So the z-score for that, so you look at the vertical direction, that's the z, and that's the decimal. So it'd be negative 2.30. So this is the z equals negative 2.30. That's the z-score that corresponds to 1% of the area to the left. All right, so hopefully you're getting the idea. Now let's take a look at the third one. So for third one, we want to find the area to the right. So I'm just gonna put this down here. Now remember, when you read of the z table, you get the area to the left. So when you're looking at to the right, you have to do a little bit of calculation on that. So let's draw the picture and then we'll see how to look at this. So this is not so normal. Let's suppose this is the normal curve. And we know the mean is right here. So 10% of the area to the right. So we want 10% to the right. So that means we are looking at something right here. So 10% to the right. So I'm just going to write, well, we're looking for the z value, right? So we're looking for what is the z that corresponds to 10% to the right. So this is 10%. Now, looking at 10% to the right is equivalent to 90% to the left. So if I can find the z-score for this, that is the same z that corresponds to 10% to the left, right, sorry. So 90% to the left is equivalent to looking at 10% to the right. So that means this is the same z that will correspond to 10% to the right. So if I can look for 90% of the area to the right, to the left, then you're going to use the same z for 10% to the right. So we're going to look for, so this covers 90%. So we're going to look for 0.9 on our body of the z table and read off what is the z, because that's the same z that will correspond to 10% to the right. So look for 0.9 in the body. So it's going to be more down here because these are the bigger area, covers bigger area. So 0.9, so these are pretty close. And as you just continue on, you'll see that this one is pretty close too. 0.89, that's also very close. Even this one too, pretty good. So you can go with either of those z values. So I'm going to go with, let's see, let's go with not these. Let's go with that one. I think that's pretty close. Or you can even go with, maybe this is a better one too. Any of these are pretty good. You can use z equals, so this will be for 1.2, 8, or 9. Any of those are fine. So I'm going to go with 1.29. That's pretty okay. So this z is going to be 1.29. So that's the same z that corresponds to 95% area to the left, which is same as 10% to the right. Now let's go ahead and finish up the last part. So we are looking for 25% of the area to the right. So we'll do the same thing like the previous one. So I'm just going to copy it right here. So 25% of the area to the right. So again, you try to draw the normal curve and see which direction you're looking at. So we're looking for 25% of the area to the right. Let's just say that. So 25% to the right. So I'm looking at this one. So that means I'm looking for what is the z that corresponds to that. So 25% to the right. But if I read out the z table for this, I wouldn't find it because everything is to the left. That means I need to look at this much, 75%, because the total is 100%. So if I can find 75% to the left, then that z is equivalent to 25% to the right. So we're going to look for area of 0.75. And that z will be the one we're looking for. So 0.75, going back to this table again. So 0.75, so we know that that's a little bit greater than 0.90 that we looked at previously. So you can see that these numbers are pretty good, right? So let's see which one is better. So 7.5, these are good. And then this is also good. Okay, this is too much, so I don't want that one. So I'm going to go with, any of those are fine. Let's go with 0.745 because you can round it up. Or actually, the one next to it is better. So I'm going to go with that one. That's pretty good. So that will be the area for z-score 0.67. So our z is going to be, so the z is going to be 0.67. So that's the z-score that corresponds to 75% area to the left or 25% to the right.